Hi, my name is Brukayu. Today I'm going to talk about integration by parse. All right. So far, what we know about integral is that we can basically do two things. If it fits our integration table, we're good to go. We don't have any problem. But if it doesn't fit our integration table, the only thing we can do is to make it fit, or substitution to make it fit. All right. I'm gonna start from the product rule. All right. F of d by dx of f of x times g of x is equals to f prime of x times g of x plus g prime of x times f of x. So I'm going to start from the product rule and I'll try to undo the rule. The inverse of the derivative is integral, so let's integrate both sides. The integral of d by dx of f of x times g of x dx is equals to the integral of f prime of x times g of x dx plus, since this is addition, I can rewrite this part as two integrals. So what I'm going to get is again the integral of g prime of x times f of x dx. All right. So if I take the integral of f of x g of x, what I'm going to get is f of x times g of x. All right. These parts will cancel out. And what I'm going to left with is the integral of f prime of x times g of x dx plus again the integral of g prime of x times f of x times dx. All right. My step 2 is going to be, I'm going to solve for f g prime of x f of f dx. So what I'm going to do is I'm going to isolate on one side this part, and I'm going to subtract the integral of f prime of x g of x dx from f of x dx. So I'm going to now write this one here again. The integral of g prime of x times f of x dx is equals to, I have my f of x gx minus, since we're gonna move this integral to the left hand side, our sign is gonna change to minus the integral of f prime of x gx dx. All right. Now we are going to do we're going to use some symbols just to represent some of the functions. So what we are going to do is we are going to call f of x with some variable and g of x. So if we say like u is equals to f of x and v is equals to g of x, so their derivative of this function will be du, which is equals to f prime of x dx. The same thing for v, we will get dv, which is equals to g prime of x. Now we can substitute to the formula we just derived. So instead of g f of x, I can use u. At the same time, for g prime of f x dx, I can use dv. So what I'm going to get is, instead of f of x, I can use u times, instead of g prime of x dx, I can use dv, which is equals to I can use u instead of f of x, and instead of g of x I can use v, minus the integral of, so I can use v instead of like g of x times, instead of g prime of dx I can use du. So this is our formula to use integration by parts. Alright, before we solve any problem, I'm gonna make a note which is very helpful while we are going to use u and v. Alright, choose u so that the integral of v is possible. V is and so that the derivative of u is better. Alright, note that this doesn't always work, but I found that it is a good way as an indication. Alright, let's do some example now. Alright, solve example. Solve for the integral of x dx. Alright, I'll choose u to be x, and I'll choose v, which is equal to the integral of ex dx. From here we can get du, which is equals to dx, and from here I can get the value of v as ex, since the integral of e to the power of x is ex. Now I have this part, so I can use my formula and can easily substitute them, and in that way it will be easy to use integration power to solve the equation. So our formula is the integral of u dv, which is equals to u times v minus the integral of v du. All right. So the integral, I can use u instead of I can use x instead of u. So I don't have any problem with that. And the integral of dv is equals to e to the power of x dx. All right. Now I can use u instead of u. I can use x, and instead of v I can use e to the power of x minus the integral of, instead of v I can use e to the power of x times du is equals to dx in this case. All right. All right, this is my equation, which is equals to, so this part is already solved, I can rewrite it again, minus the integral of e to the power of x is ex from my integration table plus c. So this can be the final answer, or we can rewrite the equation isolating the common factor. So in this case my common factor is e to the power of x, and x minus 1 plus c is my final answer. E to the power of x, x minus 1 plus c. This is my solution. All right, let's do another example. Example 2. Integral of x cubed times ln of x dx. All right, I can let's say u is equals to ln of x, and let's use v. The integral of v is equals to x cubed dx. From here I can get du is equals to 1 over x dx, and my v is equals to x4 over 4. All right, these are the parts that I can use in my formula to solve the problem. All right, let's bring the formula again. Integral of u dv is equals to u times v minus the integral of v times du. Now I have all my parts, so I don't have any problem to substitute them. All right, the integral of u, instead of u I can use ln of x times x cubed dx is equals to, instead of u I can use ln of x times, and my v is x4 over 4 minus integral of my v is x4 over 4 times my du is equals to 1 over x dx in this part. This is always equals to ln of x times x to the power of 4 over 4. I can take the constant out of the integral, so and I can cancel the denominator from the numerator 1x out. Then I'm gonna left out with only x cubed dx. All right, ln of x to the power of 4 over 4 minus 1 over 4, and the integral of x cubed is x4 over 4 plus c, and this can be our final answer as well, but if you want we can isolate the common factor out and rewrite it again. So I'm gonna write the equation again. X cubed times ln of x dx is equals to, so our common factor is, I do have 1 over 4 here and here the same thing, and I do have on the both sides x to the power of 4 over 4. This is our common factor, and what we ended up left on the left hand side is only ln of x minus on the right hand side only 1 over 4 plus c. So this is going to be our final answer. Alright, thanks for watching. My name is Brooke. Hello again. See you on the next